Hello everyone, good afternoon, how are you? My name is Rohit. Welcome to the session on this quick revision of this DBMS course through the PYQ. Please confirm, am I audible? Please confirm once. Please confirm, am I audible to all? Okay, let's continue. Fine, very good. Okay, so let's continue the session. Okay, so here in this session we are going to discuss we are going to revise all the chapters of this DBMS. The first is our database designs and the normalization. Second is ER model. Third is query language. Under this we are going to learn the relational algebra and the SQL. Fine. Next is our file organizations and indexing, and then transactions and concurrency control. Fine. Now see here, we know in the GATE examinations this database management system is of around we can say 7 to 9 marks. 7 to 9 marks. Fine. So now from this 7 to 9 marks we can say here around 2 to 4 marks are asked from the first chapter. Okay, database designs and the normalization. Then sometimes they ask around 1 or 2 questions. We can say here 2 marks from the ER model. Okay, now this is very important. This third chapter is very important. Definitely you can get 2 questions from this chapter. Fine, we can say 4 marks. 4 marks from the third chapter. Fine, and the last is our file organizations and indexings. You can expect same 2 to 4 marks from this chapter. 2 to 4 marks from this chapter. And the last is transactions and concurrency control. Here also we can expect 2 to 4 marks. Okay, sometimes they ask questions from the indexing, then they will ask 1 question from the concurrency, or maybe sometimes they ask 2 questions from this, then that time they will skip the questions from this 4th chapter. Fine, very good. Am I audible? Please confirm. Am I audible everyone? Okay, now see here, so already in that practice session, okay, so already we discussed questions on this database designs and normalization part. Now we are going to start from the ER model, then we will move to the query language, then file organization, and then transactions, and at the end, if time permit, then we will discuss this normalization part also. Understood? Now let's go here. Okay, so this is now our test series plus. If you want, still we are having time, you can join and start giving the full length test where we are offering here 40% off on this test series here. Fine. Next is our classroom program, live online GATE program here. You can join here, and we are offering around 800 plus of hours of live teaching, and under this we are going to this hard copy of this 34 year of PYQ questions. Fine. Then to our 12 personalized mentor, one-to-one mentor sessions, and along with this we are going to provide you 130 plus test series. Fine. So if you want, you can just connect on this number, they will provide you the free counseling. Next is our zero free program. If you want, you can join this zero free program. So it is free of cost. You will get 50 plus hours of this concept videos, then 2024 paper and all this, okay, offering. Now let's move to the next year quickly. Okay, the first chapter we are going to learn this year is ER model. Fine. So under ER model we are going to revise everything, then we are going to solve some questions of PYQs also, and some personal questions. Okay, fine. Now see here, okay, so let's quickly revise everything here. Fine. See, now first thing is our introductions. Okay, so we are already studied in the classroom that ER model is nothing but entity relationship diagram is nothing but used to represents the diagrammatic design of this DBMS. Okay, diagrammatic design of the database. Fine. So this is nothing but our high level design of the database. Fine, very good. Now in the ER model, the main components of the ER model are nothing but 3 things here: attribute, entity sets here, now relationship sets. These 3 are the main component of the ER diagrams. Fine, getting my point now? Fine. Now see here, next is our, so here see in the entity sets here, see here, what is entity sets here? So it is a set of entities of the same types denoted by the rectangular box. in a ER diagram. Fine. So here the entity sets represented by the rectangular box in a ER diagram model. Fine here. So entity can be identified by a list of attributes which are the placed in a oval shape. Means let's see an example here. See this employee is one entity set. Fine. Now this employee is having some properties, or we can say this employee entities can be represented with some properties, and that properties is nothing but our attributes like EID, date of birth and ages are the properties of this employees. Getting my point now? So here maybe we can say this EID is our key attributes through the underlined form. Fine. Now see, next is our attributes. Attributes here, see. So again, so attributes are used to define the properties of any entities here in the entity sets. Fine. Now see what type of attributes we can have here. See, we are having this normal attributes through the oval shape. We represent through the oval shape. Now here we are having the key attributes. Key attributes means we are having oval shapes and the attribute will be underlined. Fine. Next is our derived attributes. Like here A is our derived. It will be in the dotted line. Fine. So now derived means no need to store these attributes in the relational or tables. Fine. So you can derive this value of this attribute value through some stored value. Okay, like we can say here age is or we can say our here this age is our derived. Why? Because we can calculate the age through the date of birth here. Fine. So we can say our system date and minus date of birth. Okay, you will get the data, or we can say we'll get the employee age here. So this age is nothing but our derived attribute. Fine. Then next is our here composite attributes here, attributes which can be represented as a two or more attribute. Like here A. So A is our composite attribute. Okay, composite attribute. Here this A is represented by two or more attribute, like here B, C and D. So this A is represented by two or more attribute. That's why this A is called the composite. We can say here this attribute composite, maybe we can say here address. Address is nothing but our composite type of attribute. Maybe this address may be represented by two or more, like here street number, area or pin code, anything. Fine. Done. Now next is our multi-valued attributes. Means if any attributes is having multiple values, set of values, then that can be represented through the double ovals. Okay, double ovals. Fine. Getting my point? Next is here relationship set here. Okay. So relationship sets, it is used to relate two or more entity sets. Okay. So in the ER model, this relationship sets is used to relate between the two or more entity sets. Fine here, see. So it is relationship sets, it is used to relate two or more entity sets. Fine. And it is represented by the diamond shape. Fine. Now let's take one example. See here this E1 and E2. This E1 and E2 is two entity sets, and here this R is a relationship set, and this defined between the two entity sets E1 and E2. Okay, because this R is a relationship set defined between E1 and E2, because of this we can say this is a binary relations. Binary relations means relationship defined between two entity sets. Understood? It can be ternary also. If the relationship defined between three entity sets, then it will be called ternary relationship sets. We can say like this. If the relations are 4, we can say 4 relationship sets. If the entities are n, then we can say this is a n relationship sets. Fine. Now see here. Now next is our participation. Fine. Participation means here, see here. So again, let's assume here this manager is nothing but our relationship set. Okay, this is our relationship set. Fine. Now see here. So here employee and the employee. See here. So both is nothing but our employee here. Okay. So here we can say employee manages some department. Here it will be nothing but, let's assume here it is a department. Okay. So here employee managing some departments here. Fine. Now see here. So if every entity of entity sets are participated with a relationship set, then we can say this is a total participation. Like here, see, we are having a total participation towards the department side. Means here every department entity is participating in the relationship set. What this means is every department must have the manager. Okay, every department must have the manager. It means here every department entity will participate in the managing, or we can say manager relationship sets. Understood? Now see here. And otherwise it will be called as a partial relationship sets or partial participation. When see here, there will be, let's assume we are having 100 employee. Okay, now out of 100 employee, some employee may be managing some department here. Fine, maybe there are some employee those are not managing any department. Because of that, we can say here towards the employee sides we are having a partial participation. Why? Because maybe some of the employee are not managing any department. Then those employee will not participate in the relationship set. Understood? So because of this, we can say towards the employee sets we are having the partial participation. Okay. So if all entities are not participating, then we can say we are having a partial participation. If all entities of any entity set if participating in the relationship set, then we can say we are having the total participation. Fine. Done. So here we are having example of the employee and department that we have just studied. Fine. Now see here next is our see here for the binary. So see here, so whatever we are going to discuss here in the examinations, mostly the question will based on the binary relationship sets. It means our relationship will be defined between the two entity sets. Fine. Now see here, we'll see here how to convert ER model, given ER model, okay, into RDBMS table. Done. Now see here, in the ER model, let's assume here we are given with ER model. Now in the ER model, okay, so if participation is a partial participation on both side, means here let's assume here that there is a relations defined, okay, there is relationship set defined between the two entity sets, and if both side we are having partial participation, if we are having the partial participation, then how to convert that into the RDBMS table. Fine. Now see here, so again see here, so if the mapping is one to many, okay, if the mapping is one to many, then we know that merge the relationship sets towards the many side. Okay, so we'll see one example based on this. See here, let's assume here, let's keep one to many this. Okay, now see here. So this is our relationship set given here. See this R is a relationship sets defined between the entity sets E1 and E2. Getting my points? Okay, so this is defined between E1 and E2, and see both side we are having partial participation. What is partial participation means? Here means from the E2 entity, some of the entities are not participating in the relationship set. Similarly here, some of the entities of the E1 are not participating in the relationship sets. Fine. Now see mapping is one to many. Getting my point? Understood now? So if mapping is one to many, then we know here. So in the relationship sets, how many attributes will be there here? Attribute will be the key attributes of both the entity sets here. Fine. Both the participating entity sets. So again, so it will take the attribute A from the entity sets E1, and it will take the attribute B from the entity sets E2. Understood? Now, so as per data mapping we have understood here. So because this is a one to many mapping, so we are having the B will becomes the key attribute for the relationship sets. So because this B is a matching with the E2 key, that's why we'll merge the relationship sets towards the many sides. Understood? So here this relationships gets merged towards the many sides. Understood now? Any doubt here? Any doubt? Okay, this getting merged towards the many side. Okay, now see here, in the examinations we may given with the different representation, like here see here. So this arrow represents towards the E1 sides we are having one participation, and if there is no arrow, then we can say towards the E2 sides we are having the many participation. Now see here, if I keep this arrow here, then this defines this E2 is participating with the E1 as a 1. Okay, or we can say mapping from E2 to E1 is a 1 mapping. Okay, now see there is no arrow. This defines here mapping from E1 to E2 is a many mapping. Understood? So this is just a different representation of this given of this given AR model. Fine here. So I can see if something is given here, you can extend this arrow to here, like you can give this, you can just make the alternative way here, alternative diagram here by extending the arrow here. Fine. Let's see, this is our relationship sets R. Okay, this is our entity sets. Fine. So this will becomes our one to many, same. Okay, you can extend the arrow here. If something, let's assume here, let's assume here, if arrow is given here, then again this type also becomes 1. Understood now? Mapping will becomes 1 towards the E2 side. Fine. So now for now we don't have any arrow, so this side is many, this side is 1 only. Fine. So as per the convention, we have understood that if the mapping is 1 to many and both side having partial participation, then the relationship sets getting merged towards the many sides. Understood? And it will have the it will have two relations and the it will have two relations and one foreign key. Fine. Now see here, just see here. So if you are having a one to many, then the relationship set, okay, the relationship sets merge towards the many side. Fine. So it means we are having the two relational tables and one foreign key. Fine. Now see again same, just opposite, both are same only. If you are having either it is a many to one to many or many to one, both are same only. Fine. So if it is having one to many, then we will merge the relationship sets towards the right side. If it is having many to one, then we will merge the relationship towards the left side. That's it. Fine. So if it is having many to one, simply here again merge the relationship sets towards the many sides. Again we will get the two relational table and one foreign key. Understood? Done? Okay. Now see here. Next is our, if it is a 1 to 1, then see here, if 1 to 1, mapping is 1 to 1, okay, and both side we are having partial participation, then how to convert this into RDBMS table? See here. If mapping is 1 to 1, again see here, if mapping is 1 to 1, then tell me here, how many attribute will be in the relationship sets? So again we have already studied that the relationship attribute will be the key attribute of both the participating entity sets here. So from E1 it will take the A, and from E2 it will take the B here, and because this is a mapping is 1 to 1, so both A and B will form a key attribute. This is also our key attribute and this is also our key attributes. Fine. Done now. So if mapping is 1 to 1 and participation is the partial participation, then either you can merge the R towards the E2 sides or towards the E1 sides. Any one sides we can merge here. Fine. So it's up to you. If you want to merge towards the E1 side, it's also possible. If you want to merge towards the E2 sides, it's also possible. Fine. Now see. Let's merge towards the E1 sides. Okay. So this will be merged towards the E1 sides. Done. Similarly here also, this is just a different representation towards the E1 sides. Okay. So same here. So if both side having mapping is 1 to 1 and partial participation, then we will get the two RDBMS tables and two RDBMS tables and one foreign key, and foreign key will be, see here, let's design the foreign key also. So can I say here, after merging this will look like here E1 R having attributes, okay, having attributes A and B. Okay. Now here both are the key attributes, and now here we will be having the E2 attribute, E2 entity sets having attributes only B. Fine. Now this B will behave like a foreign key. It will refer to this B here. Fine. And this B is nothing but you can keep this as an alternative key or primary key, anything. Primary key or alternative key. Why? Because this is a candidate key. And this B is also a candidate key. You can keep either as an alternative key or primary key. Understood now? Very good. Now see here. So again, if the mapping is 1 to 1, then merge the relationship sets towards the any one sides, either left or right here. So again it will result into the two relational tables and one foreign key. Done. Now see, now let's talk about the last one is if mapping is many to many and separate table for each entity sets, and the relationship sets here. Fine. Now see here. If mapping is many to many, then how to merge here? See here. If let's assume here, if the mapping is many to many and both side having the partial participation, Now see here. So if mapping is many to many and both side partial participation. Now first thing is tell me here. So attributes will be the key attributes of both the participating entity sets here, A and B. Now see here, because both side having many to many participation, now here the key will be A and B combinedly form the key attributes. Getting my point? So in case of many to many with both side partial participation, it is not possible to merge this R either towards the E2 sides or towards the E1 sides. It means here this R is going to form a separate table with the E1 and E2. Fine. So here this E1 will also form a separate table with the attributes A. Similarly here this E2 also form the separate table with attribute B. Understood? Now see, if we are having the many to many participation, then how many table? 3 tables and 2 foreign key. Understood? So here this A will be the foreign key. Okay, it is referring to this A towards the E1 sides, and this B is also foreign key. It will referring to this B towards the E2 sides. Understood? Getting my point now? Fine. Similarly here also again same, E1 and R and E2. All these 3 will form a separate table. So 3 relational table will be required if it is a mapping is many to many with both side partial participation. Understood? Fine. Now see here. So if it is many to many here, separate table for each entity sets. Each entity sets means both the entity sets here. Okay. Both the entity sets will having the separate tables. Along with that, the relationship sets also having a separate table here. Fine. It means 3 relational tables and 2 foreign key required. Understood? Done? Fine. Now let's see here. Next is our. Fine. Now see here. Now see, everything is same only. Now see here. So mapping here is cardinality constraints of the relationship sets. Same here. Mapping, we will discuss all the mappings here. Fine. 1 to 1, 1 to many, and many to many. Fine here. Now see here. Now let's change the participation. Okay. Now let's change the participation. Fine. Now let's take here. Let's take here. This mapping is many to one only. But mapping is many to one only. Previous constraint was that both side having the partial participation. Fine. Now what we'll do here? So mapping is many to one. Now we'll put the full participations on one side. Full participation on the one sides. Okay. Now if we are having full participation on the one side, now see here, just example see here. So again see here. So 1 to many. This time let's keep the full participation on the one side. So if you are having a full participation on the one side, then in the classroom we have already studied that it is possible to merge them into a single table. Okay. So it is possible to merge them into a single table. Fine. Why? Because if we are having a total participations towards the E1 side, so previously the case was so we are merging this R towards the many side. So when we tried to merge them into a single table, then the problem was we are losing the partial participants towards the E1 side. But now because towards the E1 side we are having a full participation, now it is possible to merge them into a single table. Understood? So here E1, R and E2 will merge into a single table. Fine. Okay. Understood now? So here so E1, okay, E1, R, E2, all this gets merged into a single table, and attributes will be here A, B and so on here. Fine. And the key attributes will becomes the B. Okay. This B is our key attributes, or we can say candidate key. Fine. So we are having a single table, only one table and 0 foreign key. One table and 0 foreign key. Understood now? Now same here. So now if I keep the total participants towards the one side, then what will happen? Then complete table getting merged into a single table. This table will merge into a single table. Understood? Done na? Okay. Now see. So first point is clear. Na? So if the mapping is many to one, on one side, if you are having a full participation, then what will happen? Then merge the entities and the relationship sets into a single table, single relational table. So how many relational table will be having? In this case, we are having a only one relational tables and 0 foreign key Fine. Now see other case here. Now see, mapping is same only. Mapping is many to one, but the full participation is towards the many side. Okay. Now the full participation is towards the many side. Now see in this case, see here. Now see, let's take the same here. Mapping is one to many. Now keep the total participations towards the or full participation towards the many side here. Fine. So towards the many sides we are having the full participation. Then again see here. So if we are having a full participation towards the many side, then again see here. Again we understood here in the classroom we have already studied that if you try to merge them into a single table, then what will happen? We will lose the partial participations towards the even side. That's why here it is not possible to merge the R into a single table. Understood? So in this case, if we are having a total participations towards the many side, then this R, okay, the relationship set get merged towards the many sides. That our standard way. Okay, fine. So here the R getting merged towards the many side. Fine. So here we'll be having the E2R with attribute here B and A, and B will be the key attribute. Similarly, we are having the attributes here, entity sets E1 having the attributes A, key attributes. Fine. Now this A will behave like a foreign key. It will refer to this A. Understood na? So if you are having a two entity sets and mapping is one to many and full participants towards the many side, then what will happen? The relationship sets get merged towards the many sides. Getting my point here? Done. So how many tables? So two tables and one foreign key. Two tables and similarly here also the relationships gets merged towards the many side. Fine. Many side. Very good. Now see here. So okay, full participations on many sides of many to one relationship sets. It means here merge the relationship sets towards the many sides. So finally we'll be having the two relational tables and one foreign key. Okay, and one foreign key. Understood? Fine. Now see next concept is see here. Now one to many is done, many to many and one to many is done here. Now let's see here. Second is one to one or many to many. Now see full participation on any one side, sides of one to one mapping. Fine. So if mapping is, assume here, if the mapping is one to one, okay, and take any one sides, either left or right, take any one sides as a total participation. Then in that case, how to find the RDBMS table? Okay, minimum RDBMS table. Fine. Now see here. So if mapping is one to one, okay, if mapping is one to one and take any one side, total participation. Let's take the towards the E2 sides we are having the total participation. Fine. Towards the E2 sides, if you are having the total participation, then tell me here how many minimum table here. Previously if the mapping is one to one and if both side having the partial participation, then we have seen here either you can merge the R towards the E1 sides or towards the E2 sides. Getting my point now? But it was not possible to merge into a single table when both side having the partial participation. But now if any one sides, either left or right, either towards the E1 sides or towards the E2 sides here, if any one sides is having a full participation, total participation, then it is possible to merge them into a single table. Understood na? Done. So it means here the relationship sets and along with the entity sets, it will be merged into a single table. Understood? So it means here this E1, R and E2, it will be merged into a single table, and attributes will be here A and B and so on. Here A and B both will form here. A and B both will be the key attribute. Both will be the key attributes. Getting my point? A and B both will be the key attributes. Done na? Fine. Now see, similarly here also, if both sides, if any one side, if we are having any one side total participation, then in that case it will emerge into a single table like E1, R and E2. Understood? A and B both may be the key. This is also key attributes and B is also our key attributes. Fine? Done na? Now see next is here. Okay? Next is many to many. See here. Now see, read this one. Fine. So now see, if mapping is 1 to 1 and any one sides, if you are having a full participation, then merge the entity sets and relationship sets into a single table. Getting my point now? Now see other cases, if mapping is many to many, and full participations on any sides, okay, full participations on any many sides. In that case here, our relationship sets, merge towards the many sides is having the total participation. Fine. It's not any here. Not any. So the relationship sets merge towards the total participation. Okay, total participation many side. Understood here? Now see here. So what this says here, let's skip here. Towards the E1 sides we are having total participation. Fine. So towards the E1 sides we are having total participation. Then in that case, so previous was when we are having many to many mapping and both side partial participation. Then in that case, entity sets and relationship sets all having the separate table. We are having the 3 tables and 2 foreign key. But now here, if we are having any many sides total participation, then in that case here, relationship sets will be merged towards the many sides with having the total participation. Understood? So in this case, this are getting merged towards the E1 sides. Why? Because the E1 sides we are having the total participation. Fine. Here we are having the total participation. Understood na? Fine. So in this case here, this are getting merged towards the E1 sides and E2 will form a separate table. Similarly here also, if we are having E1, means here if we are having the total participation, then we can say this R is getting merged towards the many sides. Fine. Okay, done. Now see here. So here in this case here, so E1 and R, it will form one table. One will be A and B. Similarly here the E2 will form another table with the B. Fine. Now here this B is nothing but our foreign key referring to this B. Fine. And here A and B combinedly forms here A and B combinedly forms the candidate key or the key attributes, and here this B is a key attributes, already you know. Understood na? It means if both side is participation is, or we can say mapping is many to many, and any many sides, if we are having total participation, then relationship sets get merged towards the many sides with having the total participation. Fine. Done. So in this case 2 table and 1 foreign key. Okay. So in this case we are having a 2 relationship sets. Okay. 2 tables here and 1 foreign key and 1 foreign key. Done. Fine. Now see here, next is see here, last variation is here. So if mapping is anything, either that is 1 to 1, one to many, many to one, or many to many. Mapping is anything if both side is having full participation. Okay, so if both side, okay, having full participation, then it will be having a single table. In all that case, if participation is total participation on both sides, this is compulsory, that total participation must be on the both sides. Okay, then in that case here, merge the entity sets and the relationship sets into a single relational table. Okay, so ultimately here, in all the case, whether it is a one to one or many to one or many to many or one to one, if both side is having total participation, then here relationship set getting merged along with the entity set and it will form the single table and zero foreign key. Okay, single table and zero foreign key. Fine, single table and zero foreign key. Now see last one. Let's solve some questions here. Okay, so before this, let's solve this question here, then we'll come to this. First solve this question. Okay, we'll see about this here. This is our weak entity sets and this is our weak relationship sets. You know, here whenever we are having a weak entity sets and weak relationship sets, so always the weak relationship sets merge towards the having the weak entity sets. It will be merged into a single. Fine, try. So question is consider the given ER diagram, the number of relational table for the given ER diagram. How many table is required here? How many table is required? Fine. Now if you observe, see here. So you can see, so we are having the two entities. First is our employee and department. Fine. Now towards the employee sides, the mapping is here 1, and towards the department side, mapping is many. Okay. Here we are having the works is towards the employee side having the many, and this side also we are having the many. Fine. Getting my point now? Now see as per rule, if towards the many sides, if it is a full participation, still the relationship sets merge towards the many sides only. Fine. It means here this managers getting merged towards the department side. Okay, department sides. Then this work will form a separate table. Then this employee also form a separate table. And the relationships here, the weak relationship set, this is merged towards the weak entity set. So this is getting merged into a single table. Okay. So how many tables here? So 1, 2, 3, 4. 4 tables is required. Okay. 4 relational table. Right here, see. Let me write here, everyone. See here. So first table is our employee. Okay. With our first is this, then employee name, then the rating. These 3 attributes with the SSN number. This number is nothing but our key attribute. Fine. The second is our department and manages relationship. This is merged into a single table with attribute department ID, then department name, and then address. Fine, done. Now see, and other is, the third one is works. The third one is our works. Tell me how many attribute will be in the works relations having the attribute? 2 attributes. So it will take the key attribute from both the participating entity sets. So in the works relationship sets here, participating entity sets are employee and the department. So it will take the key attributes of employee and the department. So key attributes is our SSN number and department ID. So okay, SSN number and department ID, and this combinedly forms the key attributes. Fine, done. Combinedly forms the key attribute. Fine. And the last one is here, the child belongs to. This will form a single table. Now see this relations brings the key attributes of this employee, and that key attribute will form the strong key for this child table. Fine. So here we will be having the essence number, then name, age and gender. Fine. And this SS number is forms the key attributes for this table, final table. Fine, done. Now see let's also define the how many foreign key will be there. So 4 table is confirmed. How many foreign key will be there here? How many? 2. SSN ID, yeah, 2 table. Fine. Here 2 absolutely for this here works. Fine. So how many foreign key will be there? See here. So now see this department number manages. So this managers here will be having this. Okay. So here will be having one more attributes in the department and manager. It will brings the key attributes of this employee. Okay, key attributes of this employee. Fine. So here we will be having the key attributes here. So it will take the SSN number and or let's skip here department ID and SSN number. Fine. So here this department ID will behave the key attributes. Now see here. Now this SSN, this will becomes the foreign key and it will refer to this. Done. Now this again, this SSN number, this is also behaves like a foreign key and this will point to this here in the employee table. This department ID, this is also our foreign key and this will points to this department. We can see here. You can just represent here. Fine, properly. Now see this SN number is also behaves like a foreign key and it will point to here. So child's employee. So again here employee. Understood now? So how many foreign key? Here 1, 2, 3, 4 foreign key. 4 foreign key. Prabha 4 foreign key. Not 3. Yeah, 4 foreign key. 4 foreign key and 4 table. Fine, very good. Now let's solve the next questions quickly. Solve these questions and tell me how many minimize, or question is how many total attributes required for the minimized relations for the given ER model. Now for the ER model, first convert this into the relational table and then see how many total attributes we are having. Total attributes. Quickly try. Fine. First see mapping is, if you want you can write the mapping also. Okay, here it is 1-to-1 mapping, here many to many, between the E1 and E2 many to many, between E1 and 4 1-to-1 mapping, E2 to E3 1-to-1. Fine. E3 to E5 having 1 to many, and this is nothing but the weak relationship sets. R6 is weak relationship sets, and here is many to many is a self-referential relationship sets. Fine. Quickly try. How many table? 7 table. Okay, let's try here. Fine. Now see as we already discussed here, when we are having 1-to-1 and any one side total participation, then this getting merged into a single table. Fine. This is a single table. Fine. Now here many to many, both side partial participation, it means this is having a separate table. Fine. Similarly see here. So again see here. So 1-to-1 and 1-to-1 along with 1-to-1 we are having the both side having the 1-to-1 and one side is having a total participation. It means this E3, R3, E2 will merge into a single table. And if you want you can also keep this R5 here, because we are having 1-to-1. So either this R5 can merge towards the E4 side or towards the E3 side, any one side. So let's keep here. Let's keep this into this sides only. Fine. Done na? So here this complete is one single. This complete is a single. Fine. Done. So 1, 2, 3, and this will forms a separate table because this is a many to many, both side partial participation, and the last one is this only. Fine. I did not count the self-referential. Yeah, here we will be having self-referential. Last one is R2 is self-referential. Done na? So here having R1, R2, R3, R4, R5 and R6. 8 table. 1, 2, 3, 4, 5. How this 8 table, Baba? Baba, how this 8 table? Only 5 table. 5. 1, 2, 3. This complete is 3 table, and here is our 4, and last one is 5. Understood? See here. So 1 to 1. Where did you gone wrong here? Understood here? See. So if mapping is 1 to 1, and any one side total participation, as we discussed here just, okay. So if mapping is 1 to 1, okay. So if mapping is 1 to 1, and full participation on any one side, okay. If mapping is 1 to 1 and full participation on any one side, this gets merged into a single table, okay. Fine, yeah, fine. So here it will be having how many tables? Okay, here how many tables here? 1, 2, 3, 4, 5 tables. Fine, very good. Now let's quickly write the attributes here. Now see here. So first is our E1, R1 and E4. E1, R1 and E4. Attributes, tell me here. Attributes will be here A, B, C, K and L. Fine. And here A is our key attributes, and this K becomes also the key attributes. Fine, very good. Now here the next one is this is our R1. This is R4 na? Okay, this is R4. Fine. Now here is R1 only. So now R1, how many attributes here? So this R1 will take the key attributes of both the participating entity sets. So participating entity sets are E1 and E2. So from these two it will take the key attributes. So from E1 it will take A, and from E2 it will take the D here. So here this is A and D, and both combinedly forms the key attributes. Fine. Now the third one is let's skip this completely here. This one complete here. E2, R3, E3, R5. E2, R3, E3, R5. How many attributes here? See here. Now see, E2 is having 2 attributes, D and E. Fine. Now E3 is having 2 attributes. F and G. Fine. F and G. And anything here, see R5. Now whenever I merge this R5 towards this here, so it will bring the key attributes of E4, that is our K. So along with this having key attributes. Fine. So I can see key attributes will be K is also key attributes, F is also key attributes, and D is also key attributes. All this. Fine. So 1, 2, 3, 4, 5. Understood na? So from E2 it will take 2 here. So R3 we don't have any attributes. E3 having 2 attributes, F and G, and R5 will bring the key attributes here. So how many? 5 attributes. Done na? Now fourth one is R2. Let's keep this R2 here. R2. How many attributes? It will take the key attributes from the self entity sets here. From the E2 here, it will take the key attribute D here. So I can say here D1 and D2. Okay, and both will form the combinedly forms the key attributes. Fine. Now see last one is our R6 and E5. E5, R6. How many attributes? It will take the key attributes from the E3. So that is our F. This will become key attributes, and then H, I, J. So H, I and J. This F and H form the key attributes. Fine. Now let's write here. So again, how many key attributes here, or how many attributes we are having here? Here how many attributes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 attribute is the total attributes in this RDBMS table. Understood? 18. Fine. And how many key attributes we are having? How many key attributes here? Again, how many foreign key here? Foreign key, see here. Now this A behaves like a foreign key, and this is R1. This is point to here, A here. So this is pointing to this A, and this D here. This is a foreign key. It will point to this D. Understood? Now anything else here? Now see here. Now this is E2, R2 here. This only. Fine. Now see here. So in this table, this R5 brings the K here. So this K is nothing but our foreign key. Fine. And this will point to the merge table, this K here. Fine. Done. Very good. Now see this D is a foreign key, this will point to this D, D2 is also foreign key, this will point to this D, same D here, fine. Now last is our F is nothing but our foreign key, and this will point to here this F in the table of merge table of this E3. Understood? So how many foreign key were? 5 foreign key. 5 foreign key. Prabha, how is 11? Understood? How? What is this 11? 11 attribute. 11 attribute. Are you saying 11 attribute? Foreign keys are 1, 2, 3, 4, 5, 6 foreign keys. In R2, in R2, yeah, we are having this 2 na, D1 and D2. 11 key attributes, 11 key attributes. Okay, key attributes. Let me count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, 11 key attributes is correct only. Yeah, 11 key attributes, and foreign keys are not 5. See here 1, 2, 3, 3, and here having 4, 5, and 6. 6 foreign keys. Any doubt? Sir, in R2, why are there 2 foreign key in the same D? See here. In R2, again see, this R2 is a self-referential relationship sets. Now see here. So again see here. If I find the table for the R2, fine, table for the R2, then again we have discussed in the classroom that this R2 will take the key attribute from the many side. Now see, again this R2 is participating, having the binary participation, means it will take one key attribute from the left side and one key attribute from the right side. Like here, see here. So this is many to many now. So R1 will take the key attributes from the E1 sides and E2 sides also. Similarly, see here for this R2, or let me just write it here. Okay. So for this R2, okay, let's assume here this is our relations R2. Okay. Now see. Okay. Now only thing is here the entity sets is a self-referential. It means here both sides the participating entity is same only. Means here also we are having E2 and here also we are having E2. Okay. So as per rule, it will from this side it will take the key attribute, that is our D, and from this side also it will take the key attribute, that is D here. Fine. So it means here both are D only. But to distinguish, I am writing thus only D1 and D2 like this. Understood? Getting my point? So in R2 we are having the two attribute, both will be D only, but again see, to distinguish I am writing here D1 and D2, and here both the D will combinedly forms the key attributes, because it is a many to many mapping. Understood, Prabha? Understood? Now see here. Now both the D, see here, this D1 is D only. Now this D1 will refer to this D here, and this D2 is also D. This will refer to same D here, same D. But in R1 we are having two foreign key. Both D1 and D2 is behave like a foreign key. Understood na? Fine, very good. Now this is done. Fine. Now let's solve this question quickly. Try these questions. Normal. Okay. This just comes from the normal. Okay, just let's leave this here. Fine. Self-referential. Okay, let's go for the PYQ questions. Okay, solve this question quickly. Solve these questions. Try and answer quickly. Okay, already discussed in the classroom. Fine. Again see, mapping is, tell me what mapping is here. This is a many, this is a one. Understood? Similarly here this is a one, this is a many, but this is a weak relationship sets, and because of this also will be in the weak entity sets. Understood? So again minimum table will be here, this R2 will be merged towards the n side or weak entity sides. Again mapping is one to many and total participation is towards the many sides. So because of this will merge towards the R1. R1 is merged towards the many sides or M sides. Fine. So we are having 3 table, and this will form the separate table, this P. So how many tables? How many tables? 3 tables. Fine. Done. M1 P1. Yeah. M1 P1. Yeah, absolutely. M1 and okay. M1 and P1. Fine. Now see quickly here. Let's write the let's the table here. See here. Now see here this M and R1. This M and R1 will form a table here, and attributes will be M1, M2, M3, and this R1 will brings the key attributes of P, that is our P1. Okay. Now here this M1 will form the key attributes. Option D. Okay. Let's see option D here. Fine. Now P is having a separate table, so it is having the same our P1 and P2, and P1 is the key attribute. Similarly, this getting merged into a 2 table. So again I can see here N and R2. Attributes will be key attributes of the P, that is our P1. So here is P1, N1 and N2. Fine. And at the end P1 and N1 will form the key attributes. Fine. So again as per the given data, see here asking here which of the following is the correct attribute set for one of the table for the minimum number of table needed to represent M and P, R and 1, means like here. So represent the minimum. See, we have already seen 2. If I want to convert this into a minimum table, then I require 3 tables. So out of these 3 tables, see here. So option A is M1, M2, M3, P1. This is the correct only, na? Why options D? Prabha, options D says here M1, P1, N1. Is it matching with anyone? Is this option? Oh, sorry, option D. M1, P1. See here, no. M1, P1. See here, M1, P1. This is equivalent to R1. Okay. R1 table is having this relationship. R1 is having the attributes M1, P1. M1 and P1. But if you merge this R1 towards the M side, then this R1 is not having any separate table, na? Okay. So finally, because I need to find the minimum table here, minimum number of tables here, then in case if I want to find the minimum table, then in that case here this R1 will be merged towards the M side. It will be merged towards the M side. It won't have any separate table. Fine. So if R1 is having separate table, then in that case this will be the attribute list for the R1. Understood? So because of this, option D is incorrect. Understood? Not M1, P1. So here option A is right here. M1, M2, M3 and P1 are the attributes of this M and R1. Fine. So this M1, P1, N1 is irrelevant. Similarly here M1, P1. M1 is this only. P1 here, N1. This is also irrelevant. Fine. Understood? Prabha? Done? Any doubt? Understood? Prabha, any doubt? Okay. Now let's go for the here. Next is asking here the minimum number of tables needed to represent this here. Already we have seen minimum table is 3 only, 1, 2 and 3. Okay. So minimum number of table will be 3 only. 3 means here answer is B. Fine. 3 table means here this M and R1 is merged into a single table. P is having a separate table, and here R2 and N will be merged into a single table. Fine. This is our weak entity sets. Understood? So option B is the right and all other options are incorrect. Fine. Very good. So now we are already done with everything about this ER model. Fine. Okay. Now let's see the last concepts here. We can say the self-referential. Fine, self-referential. Anything you have know already? Fine. Self-referential again. Self-referential. Self-referential means again see, it is nothing but it is also called the recursive entity sets. Recursive entity sets. Fine. So here entities of the entity sets E related to the some other entities of the same entity sets. Means here. So if you let's assume here there are attributes, A attributes in this, and we are having the B attributes. Fine. So self-referential means see here. So E is having two attributes. One is the A and one is the B. A is the key attributes. Now see here. Let's assume here. So this R is a relationship sets defined with the E here, and this is a self-referential. Now see, because this is a binary, so mapping could be anything. Either this could be one to many, or many to one, or one to one, or many to many. This could be anything. Fine, understood. So now if I made here for the R, if you take the table here, so as per the convention, this R is having two attributes. Okay, it will take the key attributes from this left or right, both side here. So again it will take the A attributes and A, both will be the key attributes. Fine, here A1 or A2. Now as per convention, if we are having this one to many, then A2 will become the key attributes and it will merge towards the A2 sides. Understood? So again it is a many to one, then this A1 becomes the key attributes, and if it is having one to one, then this getting merged towards either the E1 or E2 sides. Okay, we have already studied in the classroom. Fine. Now see, if it is many to many, then this R will form the separate table. This R is having the separate table and this E is having the separate table. Understood? This is all about the recursive entity sets. Fine. Now see, next is our, okay, this was the questions. Okay, you can try, just take it, try, just see, try. This is having the E1 entity sets having attributes A, B, C. This is a self-referential R1. Fine. And this is our one to many. This is our mapping is one to many, and then here it is a R2 relationship. Fine. Mapping is many to many. Fine. Both side is having the partial participation, and here the mapping is one to many. Fine. And it is a weak entity sets. Attributes are Ij, D, E, F of this E2 and E3. Fine. Quickly try here. Minimum number of relations required for the above ER model. Quickly try. Try quickly. Minimum number of relations required for the above ER model. Five. Okay. Now see here again, because this is a weak entity sets, it means this will be merged with the R3 will be merged towards the E3 sides. Very good. Now see here. So both side is participation is many to many here. Sorry, mapping is many to many, and both side partial participation. It means R2 will form a separate table, and this E2 will also form a separate table. Fine. And see here. This is a self-referential, but this time Prabha, this time this is not many to many. This time it is having, okay, E1 R1, E1 no. See here. This is the mapping is one to many. So mapping is one to many. So what we'll do here? We'll merge the R1 towards the many side. Means this relationship sets R, it will be merged with the entity sets E1. Then why you are managing the E1 separately? No need to manage the E1 separately. Understood? Getting my point? This R1 will be merged towards the many sides with the E1 entity sets. Understood? So this will be merged into a single table. Understood? Fine na? Now see. Understood, Prabha? Okay, see, as we have discussed also, like here, if we are having a binary relationship sets, this is our R, and if the entities are our E1, or we can say this is E2 and E1, fine. And if the mapping is one to many, let's assume this is a one to many, then tell me here, so which side this R will be merged? This R will be merged towards the many sides. It will be merged towards the many side, means towards towards the many side means this R will merge towards the E2 side. Similarly, same here, we are merging this R1 towards the many side, means towards the n sides here. Okay, so it means finally we are having a single table. Single table is E1 R1, fine, and attribute will be here A, B and C, but see, it will be having one more attributes A1, and this A1 is nothing but same A only, but see, while merging basically the R1 is having two attributes separately, fine. Two attribute means it will be having A1 and A2, fine, because here we are merging towards the n side, so this A2 will be merged, A2 will be merged with the A. Okay, now we left with the A1, and this A1 will also having one more attribute, fine here, understood now? So it means finally the key attributes will be nothing but our towards the A2 sides, means A2 getting merged with the A, so the key attributes will be A here, understood, and A1 is nothing, it will be a foreign key. This A1 will be foreign key, understood, this A1 will be foreign key referring to this A, understood, fine. Now next is our E2. How many attributes E2 is having? Same, yeah, it is having D, E and F, and D is the key attribute. D, E, F and D is the key attribute. Similarly here, or anything else here. Next is our R2, one more is R2, this is our second one, okay. Third one is R2. R2 having attribute, key attributes of both the participating entities, it is E1 and E2. So it will take A and D here, okay. So having A and D, and both combinedly forms the key attributes. Now talking about the foreign key, then here this A is a foreign key, it will refer to this A in the table of E1 R1, and this D is a foreign key, it will refer to this D in the R2, fine, done. Now last one is fourth one is R3 and E3, or we can say E3 and R3, fine, and attributes are here, see. So this R3 will bring the key attributes of E2, that is our D here, D, and then okay D, I, J, okay, D, I and J, and this D, I will forms the key attributes. D is nothing but our foreign key, okay, this D will be forms the foreign key, it will refer to this D, understood, getting my point? How many tables? 1, 2, 3, 4 tables, and how many foreign keys here? So 1, 2, 3 and 4. This is see, this is the example of foreign key referencing to attribute in the same table, same relation, understood, getting my point now? So how many foreign key? 4 foreign key, 1, 2, 3 and 4 foreign key and 4 table. Any doubt here? Any doubt? Done? Okay, very good. Now let's go for the weak entity sets, and then we'll start the this is done, then we'll start the relational algebra, fine. Now quickly go through this here. Weak entity sets, see here, okay, the entity sets with no key, okay, our entity sets we don't have any proper key or a strong key, that entity sets is called the weak entity sets. Like here the weak entity sets is represented through the double rectangular box, and if it is having no key means we can say that is having the weak key. Weak key is represented by the dotted line like this here, fine, okay. So here see, attributes of weak entity sets are not sufficient to differentiate the entities uniquely. We know here what is the key attribute? Key attribute are the attribute that will differentiate the records uniquely, or we can say that will differentiate the entities of entity sets uniquely, fine. So but if it is having the weak entity sets means there is no key. If there is no proper key or strong key, it means attributes of the weak entity sets are not sufficient to differentiate the entities uniquely, fine. Now see here, there are some points about the weak entity sets that for each weak entity sets there must be a honor entity sets which is having the strong key, like here like here in the previous example, if you see here, so this is a weak entity sets, this weak entity sets, this R3 is a weak relationship sets and defined between the E2 and E3, Now for here, see, for this relationship, this E2 is nothing but our honor entity sets, having the strong key. See, this E2 is a strong entity sets having a strong key. This D is a strong key here. Fine, done. Now see here, now next is our relationship sets between the weak entity sets and the identifier. Same. Identifier entity sets means this is the honor entity sets. Okay. So now here see the relationship sets between the weak entity sets and the identifier is also the weak relationship set, like here. So the relationship R3 defined between the honor entity sets and the weak entity sets. This is also behaves like a weak relationship set. Understood? Fine. This was the second point. Fine. Now third point is the participation towards weak entity sets and must be total participation. See here. So here in towards the weak entity sets, we are having a total participation. Why? Because the weak entities of this weak entity sets is dependent on the honor entity sets. Getting my point now? So the entities of the weak entity sets is dependent on the honor entity sets. Because of this, every entities of this weak entity must have to participate in the relationship set. Understood now? So because of this, the participations towards the weak entity sites must be total participation. Understood? Done now? So here third point is done, and the last point is the mapping between identifier entity sets and the weak entity sets must be one to many. Fine? Getting my point? The mapping between the identifier, or we can say honor entity sets, and the weak entity sets must be one to many. See here, if it is one to one, then if there is mapping is 1 to 1, then no concepts of the weak entity sets. Getting my point? If mapping is 1 to 1, then this will behave like a strong relationship sets. So because of this here, mapping will be 1 to many, and the participations towards the weak entity sets must be total. Getting my point? And there are need of the honor entity sets that will help these weak entity sets to define strongly. Understood? This is the concept of the weak entity sets. Fine. Done. All point clear now. Now see, if you see clearly, see here. Okay. So here this is our weak entity sets, honor entity sets or identifier entity sets. Fine. So the weak entity sets, if it is a weak entity sets, okay, represented in a double rectangular box here, and the keys will be represented with the dotted line. Fine. Okay. This is called the weak partial key, or we can say the weak key. Understood? And here the relationships R is also called the weak relationship. Understood? And mapping will be 1 to many, and participations towards the weak entity set side must be total. Now regarding the finding the number of relations table, so always the relationship sets will be merged with the weak entity sets. Understood? Always. Okay. And as per concepts also, whenever the mapping is 1 to many, always the relationship set get merged towards the many sides. So here also it is getting merged towards the many sides only. Understood? And the honor entity sets will form a separate table. Done now? So 2 tables will be required in case of the weak entity sets. Fine. Done. Next is a single point here. Again see here. So weak entity sets and the multi-valued attributes allowed to represent in ER model, but not allowed in a RDBMS table. See here. So in a ER model, okay. So if you are representing something ER model, okay. So in the ER model, the concepts of weak entities, okay, having some partial keys, and let's take one more entity sets E2 having a multi-valued attribute. It can have multiple values here, set of values here. See, both the weak entity sets and the multi-valued attributes are only allowed in the ER model. Okay. So ER model is nothing but the high level design of the database. Understood? This is only allowed in the ER model. So if you convert, okay, so if you convert this into, convert it into RDBMS table or relation, then during this conversion you need to resolve the weak entity sets problem. Means you need to convert this weak entity sets into the strong entity sets. How to convert? Simple, merge the relationship sets into a single table, it will become the strong entity sets. Understood? And the second is here we need to resolve this multi-valued attribute here. Fine. So again, how to resolve this problem? Then again simply merge this attribute along with the key attributes, or we can say along with the candidate key. It will become the single valued attribute. Fine. Done na? So whenever you are converting the problem, means whenever you are converting the ER model into the RDBMS problem, so while conversion this 2 must be removed from the ER model. Okay. So the multi-value attributes and the weak entity sets, these are only allowed in the ER model. In RDBMS table there is no concepts of the weak entity sets or the multi-value attribute. Understood? Any doubt here? Any doubt? Any doubt? Anyone? Okay, very good. Now let's go for the relational algebra and the SQL. Okay. Now see here. Let's quickly define this here. Query. Basically query is of two types. One is called the procedural query language and other is called the non-procedural query language. Like here we can say our relational algebra RA is a procedural query language, and this SQL, okay, this SQL is a non-procedural query language. Why? See here, what is this procedural query language? In this query language we need to formulate, or the formulations of, we need to specify how to access the data from the database and what data you want to access. Okay, getting my point now? So means here if it is a procedural query language, then we need to specify two things. One is what data you want to retrieve from the database, and how this data, how to retrieve this data from the database. These two things must required under the procedural query language. And so again in this array, okay, so relational algebra provide this method here. Okay, so in the array we going to see here how this relational algebra define what data required, and ultimately through the operator it will also define how we are going to retrieve the database data from the database. Understood? So this is array is nothing but our procedural query language. But see here our SQL is nothing but our non-procedural query language here. Fine. SQL. Why? See here. So whenever you want any data from the database, then simply you write the query in SQL. You are not writing how this query will be evaluated in the internet in the system. Fine. So first this SQL gets converted into the relational algebra. Now this array is going to execute on the database, and then finally the result will be produced to the user through the SQL. Understood na? So SQL is a non-procedural query language. Here user only define what data that user wants. Internally how this data going to retrieve, it is not required here in the non-procedural query language. Fine. Done na? Okay. Now see here. So in the relational algebra, see here, first important point is that this array always generates the distinct tuples. Okay. So by default, okay. So by default the relational algebra always generates the distinct records here, distinct records or tuples. Fine. So relational algebra refers to a procedural query language that takes the relation instances as the inputs and returns the relations instances as an output. Understood? Done? Okay. It means here. So in the relational algebra we are having some operators. So what we will do here, see here. So this array will take here our relational instances. Let's assume this is our R1 having some attribute here. This is the instances of the R1. Similarly here we will be having the instances of the R2. Let's assume this is our R2 and attributes are PQ, like this. Fine. Now see here. Now see what this relational algebra will do. this relational algebra, it will take instances as the input. Means here we are having some operator. So this operator will operate on the instances of the relations, and finally it will generate the result. It will generate the result as a instances, output as one of the instances. Fine. Maybe based on some operator, like if it is a cross product, then it will finally generate the result as a R1 cross product R2 having some instances, some records in this table. Okay, like this. Fine. So relational algebra will take input as instances, and after execution of the operator, it will generate the instances as a output. Getting my point? Done now. Now see next is our, okay, some of the basic operator here. Basic operator in the relational algebra is this is a projection. This is used to project the attributes. Fine, attributes values here. Now see, means in a relation, let's assume here in the relations R is having attribute A, B, C, D. Now from this A, B, C, D attributes, if you want to project only A, B, then this projection is used to project only attributes A, B. Okay. Then in the final table, we are having only value of A and B. Only, means from this table it will take A and B value, and this A and B relation sets having is nothing but our output of the projection operator. Understood? Next is our here selections. So based on the condition, it will select the record from the table, from the instances, given instances. Fine. Next is our cross product. We will see how this cross product perform here. Next is union, set difference, and the rename operator. Okay, and some of the derived operator is intersections, join, and the division. Fine. Let's see here one by one quickly. Okay, first is here our projections and the selections here. Fine, same. So from a relations having some attribute list here. Now from that attribute list, if you want to select some attribute, then for that this projection will be used here. Fine. So the notation is R and then projections operator and some attribute name here. Fine. So it is used to project the required attribute from the relations R. Okay. So from R, if you want to project some attribute, then you can use the project operator. Fine. Now here we are having this selection. Selection is here, see, R selections and some conditions P. So what this purpose is, see here. So this is selections is used to select records from the relations R, those satisfy the conditions P. Means here, see here, projections works on the attribute, and selections works on the records or tuples. Okay. So this selections operator will select the record based on the condition. If that record satisfies the condition, then it will select the record here, and here projection is based on the attributes. Understood? Fine. Now see here. This is a sample example. See here. So we are given with one relations having attribute A, B, C, and having some values here. See here. Now if you want to project from this R, if you want to project the BC here. Now see here. This is the result of the projection. This array. Okay. The result of this relational algebra here. This expression is nothing but this table. Fine. So finally we will be having that attribute B and C, and it will keep the value here. See 4, 5. Okay, then 4, 5, 4, 6, and 5, 5. So I can see here, this 4, 5 is having a duplicacy. Here will be having the repetition, and by default, it will always generate the distinct tuples. Understood na? So relational algebra always generate the distinct tuples. It will remove the duplicacy, like here. It will remove one of the value of 4, 5. It will only keep the unique value like 4, 5 only one time, then 4, 6 and 5, 5. Fine. So again, how many tuples we are having as a result of these projections here? 3 tuples. Now is here. Now next is our here selection. Now see here. So the schema of selection will be schema means how many attributes will be there in the result of this selection is nothing but same number of attribute as the original relations. So now in the original relations we are having 3 attributes A, B, C. So in the result of this selection, same having attributes A, B, C only. Fine. Now see. So how many records will be having the result of this here, result of this array expression? So it will select the record based on the condition. Here condition is A must be greater than S here. Okay, A must be greater than S, not here C. Okay, this should be C here. C. Fine. So again, second see here, first record. It will check here, is this A is greater than C or not? Tell me here. For the first record, tell me here. Is this 8 is greater than 5? Yes. Yes means it will select the first record. Similarly, is this 2 greater than 5 here? No. No. Means it will reject the second record. Understood? Similarly here, 7 is greater than 6 or not? Yes. Yes means it will select this record here. Similarly here, see, 3 is greater than 5. False. False means it will reject this record. Understood? So finally here, so after selections of the record, then it will just keep all the selected record in the result sets. Understood here? So how many records here? 845 and 746 as a result of this selection operator. Understood? Any doubt? Done? Clear? Any doubt here? Okay, now quickly, okay, let's solve this PYQ quickly here. 2021 2 marks questions. Quickly try to solve these questions. Try to solve these questions based on some probability. Okay, mathematical concept is required here. Try. Simple, basic. Okay, only based on the selections operator. We are given with one relation, fine, and we are having one selection operator with some condition, okay, and the question is the estimated number of tuples in the output of this array expressions. Quickly try. Anyone? Anyone? Okay, question says a relations R is given with attribute A, B, relation R is given with attribute A and B. Fine. So here, see here. So a relation R is given, fine, having two attributes, one is A and B. Fine, we will be having the relation R is given with attributes A and B, fine. Now see, so in relations, okay, so relation R is given attribute A and B in a relational database has 1200 tuples. 1200 means here how many record we are having? Here we will be having a 1200 records. Tuple means records only. Tuples or records, both are same, records. Fine. Now see, the attribute A has the integer value ranging from 6 to 20. Fine. Means here, now see here, in this attribute A, the values are nothing but range from the 6 to 20. Means here 6, 7, 8, like this we are having some 20 values. Understood? 6 to 20. Similarly here see, the attribute B has the integer value ranging from 1 to 20, like here 1, 2, 3 up to 20. Okay. So any combinations, like here we can say any combinations of this, we are having a 1200 records. Understood? Fine. Now see here, it says here, assume that the attribute A and B are independently distributed. Like here all are independent, means here this A can combine with anyone. 6 can combine with 2, 3 or anything. Okay, similarly 7 can combine with any value here. So all are independently distributed. Fine here. Now see the estimated number of tuples in the output of this. Fine. Now see here, now see the RA expressions here. The RA expression is given on R. We are selecting we are selecting the tuples with A greater than 10 or B equal to 18. B equal to 18. Now see. So I can see because the condition is OR, so we will select the record if A value is greater than 10 or the B value is greater than B value is equal to 18. So in any case we will select the value. Understood? Fine. Now see. Next is here see, because the actual records are not given. Now we have to find. So what is the probability? What is the probability that A value will be greater than 10? Tell me here. So what is the probability to get A value greater than 10? Understood? So now the question will be, now the question is here, see what is the range of A? Range of A is from 6 to 20. Now tell me here. So how many value will be having more than 10 here? How many value we can get more than 10 here in the A here? So from 11 to 20 is nothing but 10 values. Getting my point here? And total is our 15 values. From 6 to 20 is 15 value. Fine. So out of 15, see here, out of 15 I can have 10 values that is having A greater than 10. Means whenever this 11 will be joined with anyone, we will select that record. And similarly here, if this 12 joined with anyone, I will select that record. Why? Because for these records this condition will be true. Getting my point? Understood? Similarly see here. So what is the tell me here, what is the probability that B is equal to 18? B is equal to 18. See here. What is the probability that? Again see here. How many value we are having? 20 values. So out of these 20 values, how many value we are having B equal to 18 is only one. So probability will be 1 upon 20. Okay. So this is the probability to get A greater than 10, and this is the probability to get here B equal to 18. Understood? Getting my point here? Now see. So whenever I am trying to get this value here, see. So again there will be some record where we'll be having this, okay, A greater than 10, okay, and also here, and B is equal to 18. B is equal to, like here we can say here. So whenever this 11 joined with the 18. Similarly see here, when this 12 joined with the 18, 13 joined with the 18, okay. So I can see these values getting counted twice here. So once we counted in this here probability A greater than 10 here, and we also counted these records in a B equal to 18. Understood? So we need to remove this duplicacy, or we counted this twice value here. Fine. So again, how to find this probability of getting A greater than 10 and B equal to 18? How many probability we are having such probability here? Nothing but this is equal to again see, probability getting A greater than 10 is nothing but 10 by 15 and 1 by 20. Getting my point? If you found this, if you find this value here, so clearly it will say here how many value we are having? 1 by 30. Getting my point here? 1 by 30 is the probability to get in a record where A is greater than 10 and B is equal to 18. Fine. Now see here. So as per probability conditions, so if I want to find here this condition here, what is the probability to get A greater than 10, okay, or B equal to 18? Okay, so we know from the probability theorem, we can say here probability of A getting 10, then plus probability of B equal to 18 minus probability of A greater than 10 and B equal to 18. Getting my point? Just put the value here. So it is nothing but, this will be nothing but our 10 upon 15 plus 1 by 20 minus 1 by 30. So this value will be our 41 by 60. Fine. 41 by 60. Understood? So this is the probability to get the record with the A greater than 10 or B equal to 18. Fine. This is the probability, and probability again we know we calculate based on the one value. Fine. One record. So again, how many records total we are having? 1200. So finally, if I want to find the number of records in the output, let's write here number of records in the output here. Number of records or tuples in output it will be equal to 41 by 60 multiplied by 1200. It will be equivalent to, I think here it is 20. So this is nothing but our 820. Fine, 820 is the answer. Fine, means here if you apply the condition here, selection condition, then finally we are having 820 records in the result of this R expression. Tell me, any doubt here? Sometimes they can ask the probability based question also, some basic probability here. Any doubt here? Anyone? Any doubt? Any doubt? Okay. Now let's go for the next here. Quickly see what this cross product is. Cross product is, see here. Cross product. So basically this cross product here, R cross product S is nothing but it results all attributes of R followed by all attributes of S. Means if I talk about the schema, see here, let's assume there is a relation R having attributes AB. This is our R relations, fine. And if I talk about the relation S also, relation S having attribute PQ. Okay, if I want to find the cross product of R and S, then the result will contain, see here, the result table of R cross product S will contain all the attributes of R followed by all the attributes of S, that is our A, B and P and Q. Understood? Getting my point now? Now see here. So again second see, this is nothing but a schema. Okay, the first statement define the schema of the result table. Fine. Then and what this cross product is, this will do. It will each record of R, it will be paired with every record of the S. Means here every record. Okay, let's see here having the record 1, record 2, record 3. Similarly here having the record 1, record 2 and record 3. Then what will happen? Every record of the R, it will be paired with every record of the S. Okay, similarly here R2 getting paired with every record of the S. Similarly R3, it will be paired with every record of the S. Fine. So here this cross product basically it will pair each record of the R with every record of the S. Understood? Now tell me here, if number of records in the R will be having N and number of records in the S, if you are having M, then how many records we are having in the result of R cross S? It is nothing but N into M records. Understood? So I can see this is defined as our cardinality. So what will be the cardinality? Okay, cardinality of R cross product S, it will be equivalent to cardinality of R, that is N into cardinality of S, that is M here. Fine. So cardinality of R cross product S will be here it will be N into M. And what is the degree here? What is the degree of R cross product S? Degree will be degree of R. Degree means number of attribute. So the degree of the cross product R cross product S will be degree of R, that is our 2, and plus degree of S2, that is our 4 here. Finally see how many attributes? 4 attributes, A, B, P, Q. Understood? Done na? This is nothing but our cross product. Now let's go for the next here. See here. Sometimes here, sometimes if you are finding the cross product between the R and S. Okay, between the R and S, let's assume we are having the sum AB and PQ. Okay, and in the R, if we are having some records like here R1, R2 and R3, and in the P if you have 0 records, then the result of R cross S will be having 0 records. Fine. Here the R cross S having attributes A, B, P, Q, and the result of this having 0 records. Why? Because as per the definitions of, if you want to perform the cross product, then as per definitions, each record of the R, it will be paired with every record of the S. But do you have any record in the S? No, we are having 0. It means we are unable to pair the R with any record of the S. Means finally we will getting the 0 records. Finally, the result of this R cross S will be 0 records. Understood? Fine. Then next is our see here natural join. Fine. Natural join. How to perform this here? Simple. Okay. Now see here. If you want to perform the natural join between R and S, see here, between R and S. Let's assume we are having this R and S. Attributes are, let's keep the A, B and C. And here if you are having B, C and D, then if you want to perform the natural join between any two relation, the natural join perform between this. How to perform this natural join here? It will perform the equality between the common attributes. Fine. So again it will check the equality between B and B, common attributes is B, is it equal or not, and the C equal to C or not. If you are having more than two attributes, then both equality will be checked here. Fine. And then finally the result will contain, see here, the R join S, result will contain distinct attributes. Why? Because see, anyhow whenever we are comparing the B equal to B, so B value will be same, C value will be same. That's why we are merging this B or C to make this only single attribute. Fine. So it means the result of R join S will be having distinct attributes like here A, B, C and D. So finally it will be having A, B, C and D attributes. Fine. Done now. So I can see here. So what is this natural join? Natural join nothing but equivalent to first perform the cross product. Okay. First perform the cross product. Miss here. First join each record of the R with every record of the S. Then perform the condition. Condition is that equality between the common attributes of R and S. Getting my point? Miss here the first record of the R, it will be paired with the record of S only if B is equal to B and C is equal to C. Similarly here the first record of this R, it will be paired with the second record only if B is equal to B or C is equal to C. Understood? So again it is similar to first perform the cross product. Miss first pair each record of the R with every record of the S and then apply the condition. Condition is B equal to B or C equal to C. Okay, B equal to B and C equal to C. If condition is true, then select that record. Understood now? Fine, we have already seen the classroom. And then finally project the distinct record. Done? Very good. In the example, if you want to see here. So we are having two tables. One is T1 ABC and one is T2 is BCDE. Fine. Now if I want to perform the natural join between T1 and T2, it will be first perform the cross product. Means every record of the T1 it will be joined with every record of the T2. And then after this cross product, then apply the condition. Condition is T1 dot B equal to T2 dot B and T1 dot C equal to T2 dot C. Why? Because in this both the table B and C are the common attribute. Only B and C are the common attribute. So it will check here B is equal to B and then C is equal to C. Getting my point? If for any record, if the condition is true, then that record will be selected, and finally from the result of this we will select the distinct attribute, means A, B, C, D, E. Understood? Getting my point? Then one more important point. See here, sometimes what happen here, whenever we are given with two relations, okay, sometimes we don't have any common attributes. In that case here, okay. So in that case, whenever you don't have any common attribute, then the natural join is equivalent to the cross product. Why? See here. So if you don't have any common attribute, then see internally this condition becomes empty. Means here we can say here, if I want to perform, okay, T1 natural join T2, it will be T1 cross product T2 and then apply the condition. But the condition is here, condition should be equality between the common attribute. But do you have any common attribute? No. It means condition will be empty. If the condition is empty, then it will simply behave like a no effect. And finally on this, project the distinct attributes like here ABCD. And this complete table is similar to A cross product B, or we can say T1 cross product T2. Understood na? So whenever we don't have any common attribute, then similarly the natural join is equivalent to cross product and result will be equal to cross product only. Understood? Very good. Now let's go and see here, this is a conditional join. Again previous was the natural join. Natural join means by default the condition is equality between the common attribute. Now if I talk about the join, and under the join we are having a conditional join. Conditional join means here see condition could be anything. Now condition could be anything, like here see, let's assume, let's take one R having attributes, let's take the attributes AB, and one is let's take the attributes S. Okay, let's take the attribute here, this is our S, let's take the attribute here B, C and D. Fine. Now see. So if I perform the natural join here, then by default what will happen? Equality between the common attribute means it will check the equality between the B. Fine. But see here, this is a conditional join. Conditional join means now this condition could be anything. Here condition could be anything. Previously the condition was by default B equal to B. Now condition could be anything. Like here I can keep the condition as C equal to, okay, here condition could be anything, here C equal to A greater than C. Getting my point? Then in that case here see here. So again it is similar only. Okay, it is similar only. Means record of the R, it will join with the record of S only if that A value is if the A value is greater than C. Okay, if A, let's assume here it is having 10 and here the C value is 5 only. So again, is it possible to join here? Yes. Why? Because A value is greater than the C value. In that case, the first record will be joined with this record. Understood? So again, the record of R, it will be joined with the record of S only if the condition is satisfied. Okay, and here condition could be anything. That's why here see, the conditional join is equivalent to perform the cross product and then apply the condition. Like first join each record of R with every record of S, and then after joining then apply the condition. Okay, first join every record here, every record of the R with every record of the S, then apply the condition whether A is greater than C or not. So if condition is true for every pairing, means for any pairing, if the condition is true that A is greater than C here, then simply select the record. Understood? Okay, so first pair each record of R with every record of S, then after pairing then apply the condition that A greater than C here. If this condition is true for any pairing, then that record will be selected for the final result of this conditional join. Understood? Getting my point now? Fine. So tell me here, what will be the result table of this R cross product S? Result table of this, nothing but here see, all the attributes of R followed by all the attributes of S, like here A, B, and then from S it will be B, C, D. So these are the attributes of R, these are the attributes of S. Fine. So here previously see here in natural join we are only finding the distinct attributes, means here we are merging the common attributes at once here, but see here we are not going to merge. Why? Because sometimes it's possible that for any one record, see here, for any record, maybe it's possible that for any record, I can say here there is one record with it is a 20 and C is our 10 and B value maybe like here 5 and 7 or here it is 9. Fine. So for any records, if B and C are not equal, then we cannot merge into a single attribute. Getting my point here? So because of this, no, it's not ABC, it's not ABCD. It will be a separate A, B, B, C, D. Understood? In case of natural join, so I can see in case of natural join, okay, in case of natural join, see I can see here. So if you perform the cross product, then see if you perform the cross product here, okay, R cross product N, then attributes will be here A, B, C and D. Okay. Now see here, if you perform the cross product, this only fine. Now see after the cross product, if you apply the condition in case of natural join here, see, then if you apply the condition, then it will only select the record with B and B equal to B and C equal to C. Like I can say here, this is a 20 and D is anything 15 and C equal to C means B equal to B means I can say here 10 and 10 and C equal to C means 7 and 7. Now see, because for every records, B will be equal to B and C will be equal to C. Then why you are keeping 2 copy of B? So because of this, if it is a natural join, then we'll merge the B with the B and C along with the C. Getting my point? But if it is a conditional join, here this B and this B could be anything here. Means R dot B may be having a different value than S dot B. So because of this, we are not merging this B and B into a single attribute. Getting my point? So in case of conditional join, this B and this B will be different value. Understood? Clear, Prabha? Okay, now next is here. Just try to solve this question quickly. Okay, based on same here, based on this our cross product. Okay, first perform the cross product, then find the apply the condition, then from that result select the x value. Similarly, perform the cross product, then apply the condition, then select the x value, and between these two set perform the set difference. Here it is a set difference. Quickly try. You already solved this question in the classroom. Quickly try. See, are you getting or not? Quickly try. One tuple. Yes. And what is that value? Prabha? One tuple. X2. Not Baba X2. Be careful. It's not X2. What is the result of this first set? Tell me. What is the result of this? P cross product R, then condition, and then here X. What is the value of this set? First set. Value of first set. Prabha? What is value of first set? X1 comma X2. No. Okay, see here. Fine. Now see. Okay, first let's find the value of this set. Okay, value of this set. Now see here. Now here the first thing is perform the cross product. Means here we are performing the cross product between Q and R. What does cross product means? Cross product means it will join the record of Q, every record of Q, it will be paired with every record of the R. Means each record of the Q, it will be paired with every record of the R. Understood? Now see, now tell me here one thing. So again see, so how many records we are having in the Q? 4 records. 1, 2, 3, 4. All these 4, it will be paired with all the 4 record of the R. It means how many records will be in the final? Means how many record will be in the cross product of Q and R? 16 record. Fine. Now see, out of all the 16 record, it will apply the condition. Now after cross product, it will apply the condition, and based on the condition, it will select the record. Understood? Now see what the condition is. Condition is Q dot T greater than T. means greater than 2 here, means here, here. So again q dot t value must be greater than 2. Understood? Now see here, anyhow, if you join this first record with all the record, okay, because this q dot t value is not greater than 2, it will rejected in the selection procedure. Fine. So here 4 record will be rejected. Fine. Why? Because q dot t value is not greater than 2. It means here, it means see here. So first apply the condition. See just here. So I can see q dot t greater than 2 here. It means the first record will be removed from this condition and the last record will be removed. Now left with the only 2 records here. Now see, then and condition is, so again condition is that q dot y means this y and this y must be equal, then only join. Tell me here, is it possible to join this record with the first record? Is it possible to join? No. Why? Because y value is not equal. Here is y2 and here is y1. So if the y value is not equal, it is not possible to join. So leave this. Okay, fine. Now see, again, is it possible to join this record with this y3? No. Why? Because y value is y2 and here is y3. Not possible, so leave it. Again, similarly here, see. Again, is it possible to join this record with this? Yes. Why? Because here y value is same. Here is y2 and y2. Now if I join this, see here, means here finally in this table, here. So in the cross product, one of the record is selected here. Record value will be x1, y2, 5. Okay, x1, y2, 5 and then v3. Okay, so one record is this only. Fine. Similarly, tell me here, is it possible to join with this record here? Is it possible? Yes. Why? Because y value is same. Then other value will be x1, y2, 5 and v2. x1, y2, 5 and v2. These 2 records will be paired with the means here after cross product, then from the result of cross product it will this 2 record will be selected. Understood? Based on the condition. Fine. Now tell me here. See here. So here now this record is x1, y1, 6 having the y value as a y1. Fine. Y value is a y1. Now tell me, is it possible to join with the first record? Yes. Why? Because y value is same. Then again it will join here x1, y1. Okay. x1, y1, then 6 and then v1. Fine. Then again see here, say again for rest of the record the y value is not matching here, y1 not matching means here this record won't join with any other records here. Fine. So finally see from this 16 record, the result of cross product, from this 16 record only 3 records will be selected. Okay, getting my point now? So only 3 records will be selected as per the condition. Why? Because in this here see t value is greater than 2 and q dot y is equal to r dot y. Understood? Now from this project the x value. So tell me here. Project the x value means there will be one table having the x, and what x value will be projected here. See, so all these 3 records x value is x1 only. So this second record will be having value only x1. Okay, fine. Sorry. Okay, Prabha. This is x2 na. Sorry, the answer is x2 only. Fine. Here in this second set will be having x1 and here definitely here will be having x2. Okay, in these sets we are having x2. Okay, in the first sets we will be having the value of x2. Fine. So if you perform the set difference, the final result will be having the x2 only. Only x value is x2. Fine, Prabha? Correct only. Fine. Only one record as a result of this. Fine, done. So answer is only one record or only one tuples. Fine, done. x1. Okay. So here whenever we joined here, so we got here x1. Finally we got x2 minus absolutely yeah. So finally will be x2 in the first set minus x1 in the second set. So as per the set difference means set difference having result of only from the first set here. Fine. So like here first set is having x2 and this x2 is not in the second set, it means x2 will be in the result here. Fine. So it means in the final result we are having x2. Fine, very good, done. Okay, let's go for the next here quickly. Next is our our left outer join. We are having 3 types of join here: left outer join, then right outer join, and then full outer join. Fine. What is left outer join? Left outer join says here, see here. What is left outer join? It says here, first perform the first find the result of the join, natural join. This is nothing but our natural join, and then union records of R those failed the join condition with remaining attribute null. Means see here. So again, this left outer join says find the result of the natural join between R and S, and it include all the records of R those failed the join condition. Means include the records of R having here the common value is not equal. Okay, if the common value is not equal, still include all the records of R. Similarly, for the right outer join, first find the natural join, and then include all the records of the RHS, or we can say right side relation, that is our S. Include all the records of S those failed the join condition with the remaining attribute with null. Remaining attribute means here again if records of R failed the join condition, it means this R is not paired with any of the S. Then for the remaining attributes of S, in the result we are having S attributes also, then for that attribute just keep the null entry in the for the R. Understood? Similarly for here right outer join. Then last is our full outer join. Full outer join means again the union of both the left or right here. Fine. So it means first perform the natural join, then include all the records of R those fail the join condition. Similarly include all the records of S those fail the join condition. Okay, this is nothing but our left and right and full outer join. Understood? Let's quickly solve one question quickly. Let's solve this question quickly. Try these questions and tell me the answer. Then we'll try this question quickly. Try. Okay, so here we are given with two relations R1 and R2. R1 is having attribute AB with tuples 1, 5, 3, 7, and R2 having attribute AC with tuples 1, 7, 4, 9. Okay, then here we are performing the full natural outer join between R1 and R2. Fine. The schema of the full outer natural join will be R A, B, C. Why? Because the common attribute is A, and A will be merged to a single A. Remaining all will be A, B, C. Fine, done. Now consider the following tuples of the form ABC. Now here ABC the form is the first one represents the A value, and second represents the B value, and this last represents the C value. Okay. Now we are given with some tuples A, B, C, D, small a, B, C, D, E, F, G, and asking which of the following is correct. Try. First find the result set of this full outer join. Okay, let me try here quickly. So we are given with two relation. First is our R1 having attribute A, B, and other is R2 having attribute A, C. This is our R2 having attribute A, C. Fine. And values are in R1 the first record value is 1, 5. Fine. Similarly the second record is 3, 7. Fine. Similarly in the R2 we are having 1, 7, and other value is 4, 9. These two records. Fine. Now between these two I just want to perform the full natural outer join. Option C, R contains E, F, G but not AB. Very good. Already solved in the classroom. If you understood it, very good. Means option C is the right answer. Very good. Okay. Means here it is easy only. Let's quickly find one time here. Fine. Now if I want to perform the full outer natural join, it means first find the natural join result. See here, so natural join will contains distinct attributes. So in both the table, distinct attributes is A, B, C. This A getting merged. Why? Because natural join perform equality between the common attribute. So here the common attributes is A, so it will perform the equality between the common attribute. Fine. Now finally, how many attribute here? How many attribute? 3 attributes here. A, B, C. Now quickly see here. Is it possible to join with the first record? Yes. Why? Because A value is same. So first will be joined with 1, 5, 7. So 1, 5 and 7. Very good. Now is it possible with the is it possible to join the first record with the second record of the R2? No, no. Why? Because A value is not same. Similarly, is it possible to this? No and no and no. Fine. It means it's possible to join with only one, means there in the natural join we are having only single record. Fine. Anything? Yes, only single record. Fine. Now see here. So as per definitions here, it is a full outer join, full outer natural join here. Fine. So it means include all the records of R1, those fail the join condition. So here 3, 7, this fail the join condition. It means include this here also. So A value is 3, B value is 7. So here A value 3, B value is 7, and C value remaining attributes having null entry. So here it will be null. Very good. Now here same. So all records are in this join here, in the result of this here full outer join. Fine. Very good. Then from R2 include all the records those failed the join condition. Now from R2, so this 1, 7 joined with the first record, but 4, 9 this failed the join condition, means again include this record also here. So including means A value 9, also A value 4 and C value 9 here. So A value is 4 and C value is 9 and remaining value is null here. Fine. So we are having only 3 records. So if you see here, so again option C means E, F, G. So E value is 1, 5, 7 true, and then F value is 3, 7 null, yes, and G is 4 null 9, yes. Means all these 3 are there in the result of R full outer natural join S, or R1 and R2. Fine, done. And remaining, but A and B are not. Why? Because A is 1, 5 null, not in the result here. B is 1, 9, 7, is not here. Fine, so it means true. So C is true, remaining all here C. A is not in the R, it means option A is incorrect. A is not here, option B is incorrect. Similarly E, so R contains E but not F, G, no, here F is there and G is also there. Fine, it means D is also correct. Done na? Very good. Now let's go for the next here quickly. Our rename operator, then we are having some join condition, division. Okay, so we are having, already time is done, 6. Okay. Now see, remaining we'll discuss in the next session. Fine. Okay, Prabha. Remaining we'll discuss in the next session. Already time is up. Okay. Done. So all the best. Bye bye. Take care.